Good afternoon, everyone from Singapore, and good morning to all our friends tuning in from Europe. Welcome to today's session on exploring cross-sector collaborative innovation for air traffic management, which is presented by SGInnovate and Taylor's Alab. My name is Wei Min, and for those who may know, SGInnovate is a government-backed deep tech investor and company builder whose mission is to help entrepreneurial scientists build deep tech startups that are looking to solve big global problems. Our work also involves building a global community of leaders, thinkers, and doers to drive and scale up deep tech innovations in areas such as AI, healthcare, quantum tech, and autonomous technology across various industries. Today's session is our second series with Taylor's Alab in exploring innovations for air traffic management systems. To create a competitive edge and constantly coming up with innovative solutions, it is always interesting to see what is going on in other business sectors and not be limited by restrictive perspectives within one's own industry. More than often, horizontal technologies such as AI and robotics can be adapted and transformed to further enhance deep tech capabilities across various sectors both locally and globally. Our speakers today shall share more of their work and how cross-sector collaborations can bring about such achievements. We encourage for all attendees to share with us your thoughts on the topic or interact with our speakers by posting your questions in the Q&A tab located at the bottom panel of your screen. Otherwise, feel free to just say hi and do a quick shout out from where you are in the chat box below. With no further ado, do allow me to pass the time to the moderator today. We are glad to have Amartya Dave, Associate Director from Frost & Sullivan, Aerospace and Defense Practice, Asia Pacific, to kick off the presentation. Amartya, please.
Thank you, Wyman. Welcome everyone to today's panel discussion on exploring cross-sector collaborative innovation for air traffic management. My name is Amartya from Frost & Sullivan, and I will be moderating the session today. We are joined today by three distinguished industry thought leaders who are heading their companies in various capacities. And those companies are surely making headway, not only into air traffic management, but cross-sector collaboration. Our discussion today will revolve around horizontal technologies that can be applied to various innovations in air traffic management. We will be discussing on how technologies need not remain in silos, but they can be applied cross-sector, and furthermore, how they can be used to solve issues in air traffic management. With me today, I have Hugh Roderick, who is Deputy Director and Chief Product Owner at Lab Thales. The next gentleman I have is Christopher Yeo. He's the founder and CEO at Sentient. And last but not the least, we are joined by Philip Cahill, who is the Director of Sales and Partnerships at Climacell for the Asia Pacific region. I welcome all of you to the panel today. With that, I would request each of the three panelists to give a brief introduction, starting with Hugh, then Chris, and finally Philip. So over to you, Hugh.
Thank you, Amartya. So as you introduced, my name is Hugh Roderick. I'm the Chief Product Owner here at the Air Lab in Singapore. Been located here in Singapore for the last 14 odd months now, since the inception of the Air Lab. So myself, I started out, and it's hard to imagine, but 34 years ago, graduating from university, and looking back on that career, I've spent basically all of those years concentrating on one key core aspect, and that is distributed systems architecture. And that's where my main focus is. It's about implementing distributed systems and the advanced control systems that can be implemented over those distributed systems. For the last 24 years almost, I've been in the air traffic management side, all of those with Thales, and I've been lucky enough in those years to be working on products, projects, and with customers to deploy systems in more than 25 countries. So Thales, and in particular Thales in the air traffic management industry, is very global. We have customers all around the world using our operational systems as we speak now. I guess I'd summarize by saying one thing, that I think that air traffic management systems and the traditional nature of air traffic management in itself somehow does limit innovation in the necessary needs of safety and security. However, I'm certainly the believer, and I'm passionate about this, that opening the platforms and opening the technologies will create win-win opportunities for the air traffic management industry, but also, let's say, the users of the airspace, that's the airlines, the operators of major aerodromes, so the airports themselves, and of course the traveling public will benefit a lot from what opening the platforms will do in enabling more advanced technologies to be applied to the problems we face in the future. So I think that's enough from me. I'll pass the ball on.
Thank you, Hugh. Over to you, Chris.
Hi, everybody. My name is Chris, and I'm the CEO and founder of Sentient.io. We're a Singapore-based company, and our passion is to create a platform that enables software developers and programmers who are less skilled in AI and data science to be able to build smart solution using the AI models and algorithms that we put onto our platform. And so the take-up rate for our platform is incredibly high right now, and is increasing an exponential rate. So many software developers and programmers are coming on board our platform to consume ready-made, fully deployed algorithms as APIs. And our passion is to see more and more innovative startups who have created very cool algorithms to bring their algorithms on a platform and share that with many more people, so that together we can level up the quality of AI-enabled applications and benefit billions of people today. Thank you. I think it's over to Phil now.
Good afternoon, everyone. Thank you very much, Chris. Yes, so Phil is my name. I look after the sales and partnerships for Climacell. I'm also based in Singapore. I've been fortunate enough to call Singapore home for the last 7 years now. So being such a transport hub, I have passed through the Singapore aerodrome and many of the other aerodromes in the region many times. So yeah, very excited to be here this afternoon to discuss this interesting topic. Climacell, we're a weather intelligence company. And so what that means is that we actually retrieve the best weather data available, model that, and then provide that to our customers in a meaningful way that they can actually take action upon to drive efficiency and safety within those businesses there. So yeah, looking forward to a very interesting discussion this afternoon.
Thanks for that, Phil. Since I have you, I'll probably pose the first question to you. Tell us briefly about the key areas of technology and solutions that Climacell has been working on, not only cross-sector, but how you have leveraged any of those into air traffic management, solving the basic issues, probably.
Yes, fantastic. So in terms of like the areas of interest and product development on our side, naturally, being a weather technology company, it's around weather technology and the innovation there. And we really feel that we're at the forefront of that, but constantly understanding what's happening in the market there. Weather is a very complex phenomena. It is a very data heavy product there. So very interested in the innovations of cloud computing and then also data science as well. And then the last component of it there in terms of modeling, the approach that we use for ensemble modeling, very interested in the areas of innovation around machine learning and also artificial intelligence. And so at the moment, we currently work with a number of different aviation companies, helping them from their ground operations to flight planning and so forth. And we're currently, now that we've sort of, helping and have that expertise on ground, and we have that, we're now working on how we can, use that domain expertise and that data to help the air traffic management space, because the same principles apply to the work that we do with any of our clients in terms of helping them with their asset utilization, helping them with their asset protection or their passenger protection, and then also their employee safety. So all of those things are really relevant to the air traffic management, and we can apply our understanding of all of those elements to the air traffic management space.
That's very interesting to know, Phil. But another follow-up question to you would be, then when you're constantly working with various customers, whether they in the logistics space or in the aviation space, you're constantly absorbing a lot of customer data as well. So is your algorithms or your modeling are constantly evolving, and they're creating a platform where customers are able to always see a better version, or in terms of predicting the necessary? Are you also evolving the platform every few months?
Yeah, great question. So we have, like, the way we said, there's two components to our technology. There is the underlying weather data that we then feed through our products, be it the API or the web-based application that we have. And there's continuous evolution on both sides of that through partnerships with our customers. So on the data side, we've architected the platform so that we can constantly add new inputs into that. And so one of the things that we're working on at the moment through partnership with AirLab is actually ingesting weather observations from moving aircraft. And the way that we've architected our platform means that we have the ability to bring that into the data side of the product. And then on the product side, we have constant innovation based on the feedback from our clients who are using that platform to understand how they're using the API, and also how they're using that web-based application as well. So we can continuously improve those.
That's very nice to understand that aspect of the business. Quickly moving to Hugh, we understand AirLab is a collaboration between Thales and CAS, and it's quite unique in its structure as well. So could you share a little bit on the journey, how it began? I saw on your resume, you are one of the founding members of AirLab. So how has it been having those conversations in the initial stages, and how did you actually come to form AirLab to what it is now?
Okay, well, it's interesting that the AirLab has been in operation for a little over a year now, about 15 months it's been in operation. But the actual inception of, let's say, the seed where it all came from was approximately 3 years earlier. We had a time where our major customer here in Singapore, the Civil Aviation Authority of Singapore, who has been operating Thales air traffic management systems here in Singapore for many, many years, came to us and said, okay, what are Thales doing to assure the future of systems, and what are Thales doing to make sure that our future products are relevant to them? Okay, it was a real challenge, and a challenge we took up. We spent approximately 18 months going through a number of working sessions with CAAS here, basically finding out what the problems of the future might be, putting discrete and definitive elements on paper as to what the challenges would be, and then coming back with, well, how are we going to address this? And one of the main, let's say, the top tier elements that we had to address was openness of the architecture. And it's not only openness in terms of being able to share or being able to mix service solutions, but also to be open in all the technology foundation blocks. So the technology stack had to be open and substitutable. So that's where it came about. There was a memorandum of understanding signed between the VP of our general business unit, in which Thales Air Traffic Management lies, and the Director General of CAS back in February 2018. And then back in March 2019, we started some preliminary research projects. But then later in 2019 was when we actually formulated what the AirLab would be in terms of its structure, its duration, and what its mandate was. And then that led to a kickoff of the AirLab in November 2019. And the structure, as you mentioned, is quite interesting. The structure is a collaboration. It's not a customer-client relationship. It's a 50-50 collaboration. It's a contribution by both entities to investigate what solutions are to be brought forward as potential starting points for a future ATM architecture.
So, Hugh, is it the only air lab, or is air lab very global in terms of its application and evolution, or is it very unique in terms of Thales bringing this air lab collaboration only for CAS, or have you guys been doing it similar projects all over the world?
Well, Thales are very much involved in other research activities around the world. So, for instance, in Europe, there's the Single European Sky program, where as one of the industry members of the CESAR joint venture, we have contributed to many of the projects that are leading to let's say, the future concept of operations and future implementation plans of airspace management in Europe. Thales, more globally, outside of the pure air traffic management environment, also has a very active community and industrialization of innovation. Thales Research Technologies has been a long-term architectural, let's say, element of the organization, but more recently, the Thales Digital Factory was founded, I think, almost 5 years ago now, in Paris, and since then, there's been another digital factory created in Montreal and one here in Singapore, approximately a year before we instantiated the Air Lab. The unique thing about Air Lab for both Thales and I think for air navigation service providers, so the civil aviation authorities, is the collaboration structure in the sense that the team working in the Air Lab are truly a mixture. It's engineers from Thales, it's engineers from CAS, and it's operational experts from both sides as well, especially from CAS, with the heads of their air traffic management domains for future concept of operations involved directly in the Air Lab.
So once the journey began between CAS and Air Lab, how was it to receive or have those conversations with various startups? As I understand, it was a platform for having various knowledge incubations, programs with academics as well. So how was it exploring the various technological dimensions, but also how was it to work with startups in terms of their key challenges coming up?
Yeah, good question. So look, one of the, before answering specifically that question about how it was working with them, let's think about why work with them, first of all, and how. The why is because we believe, and I think the CAS as well are very much committed to this, is that entities not directly engaged in air traffic management still have value to bring to air traffic management. I think Chris referred to, let's say, small, specialized or niche startups or companies who can bring approaches to algorithmic solutions that might be very interesting in the air traffic management domain. And really, to enable them to do that, we need to have a means for engaging with them. And therefore, opening the architecture and investigating future architectures of air traffic management systems also deals with this problem of collaboration and bringing in startups or small to medium enterprises or even research institutes like universities into the game. Because what we're doing is we're opening public APIs for entities to be able to consume the services of the air traffic management system. And that is not only to be able to subscribe to the data of the air traffic management system, but also, where authorized, to be able to request a function to be performed by the air traffic management system. Now, obviously, this type of investigative collaboration through public APIs needs to be secured and needs to be controlled as to the type of environment the clients operate in. So at the moment, we have, let's say, a deployment structure where third parties would be only dealing with data fed from an offline system, not an operational system, first of all. and of course that the APIs are secured using the latest technology. Now, to get precisely back to your question, how is it dealing with the startups? Well, we're still in some of the, let's say, I'd say early phases of dealing with them. I'm finding it very interesting. First of all, it causes quite a deal of self-reflection when you try to explain a problem about a certain domain area to someone who, or let's say a company or someone who is outside of that domain. And I think it's something we would all benefit from practicing more of. And that is because if you can explain how to build a house to someone who has never built a house before, then you know you truly understand it. Okay, so that's one of the really interesting things about dealing with the startups at the moment, because we're starting a couple of projects, and it really does make you realize that you may have understood, but you haven't understood everything, and you may have thought you're prepared, but you realize you haven't prepared everything. So there's still some challenges ahead of us.
That's very interesting to note that how you created a platform and open APIs for everybody to collaborate, and there are more and more startups engaging with you. I'll quickly move to Chris. I noticed that Sentient has been working a lot on artificial intelligence, and you also have a program called Collab Program. Tell us, Chris, a little bit about the Collab Program and how it has worked so far, and what kind of companies have you been working with as customers, and how have you been developing these technologies?
Right. Today, innovation is happening at a very, very fast pace, and there are many, many innovative startups creating very deep tech, which is truly, truly innovative. For example, Phil and Clamacell here. So we're very excited to, can you imagine a world in which programmers all over the world can just come to one place to find all these very domain-specific algorithms and data to create very innovative solutions? I really like to imagine that would be such an excellent thing for programmers everywhere in the world. So what we have been doing is that we have been very obsessed with bringing in partners and API partners, and also creating our own domain-specific AI models to put it on a platform and make that accessible and easily used by millions of programmers. So we're obsessed at helping programmers discover, look for APIs, truly unique stuff, and mix and match several of these to build their very innovative AI solution for their customer base. So that's what we do every day. That's what gets us really excited. Now, the Collab program is a program that helps large enterprises, and typically these very large enterprises, sometimes they know they need AI, but they don't quite know how to apply AI in which area in the organization. So we have a program which actually helps them, takes them through a journey of problem statement discovery, as well as solution discovery. And once we have a set of potential problem statements that we know we can build solutions for, we go back to our platform, which has lots and lots of algorithms. And just like Lego blocks, we pick and choose some of these and put them together into solutions for the customers. That's what the Collab program is all about. And we have some very, very excited, very interesting solutions for enterprises today. And some of these solutions range from computer vision type of applications to voice technology type of applications. So for example, we have a national broadcaster who is using our voice technologies to do transcription of local dramas and subtitling them, right? And all the way to manufacturers in Japan, which have very high quality steel products which are used in automotive industry as well as jet engine industry. We have computer vision technology that identifies defect and classify those defects. And those algorithms are of very high quality. Right? So this is how we try to harness all the innovation that many startups and companies are building today, put it on a place where programmers can discover them and tap into them within 10 to 15 minutes. That's what we do every day.
That's very interesting to note, Chris. As you mentioned that you have certain applications into steel industry, automotive, aerospace. So what's the breadth of applications you have? So what kind of applications, industry segments have you touched upon? And if you would like to explain a particular customer case reference or how you really think that you have made a big difference over there.
Right. So so the interesting thing is the key part of this platform is cross-sectorial, right? Across many industries. And that is the power of this. Although we focus on 4 key AI disciplines, right? Computer vision, natural language processing, voice technologies, and data analytics, right? So 4 specific areas. These are disciplines, but they are horizontal in that aspect, right? So it's a nice combination of many of the algorithms within these disciplines into specific solutions. That's the key. So I'm very excited to see that some of the software developers who are on our platform creating really innovative stuff, really cool stuff. I'm very encouraged by that. But I have a team myself who actually reach out to enterprise customers who may want the solutions, right? And we meet their needs by understanding what they need to do and then reaching back into our platform of algorithms and then combining this into solutions. And I'm really actually excited about voice technologies for several reasons, right? And one of the reasons why I believe that voice technologies can make a great impact in the world today is because there are many people that are still illiterate. They don't know how to read and they don't have smartphones, right? So how do we bring the benefit of AI to these people? Is by voice technologies, right? They can speak and AI can speak to them. Right. In so doing, I'm just excited to know what other kinds of really innovative applications that startups can build using voice technologies. That is why my team and I are spending a lot of time being very domain specific. We like to do very domain specific type of voice technologies, meaning not just geographical dialects, but also sectoral type of terminology, like air traffic management terminology and all that's very different from banking and finance. So we like to really study some of these domain-specific areas and bring voice technology into those. And that's what excites us, actually.
It is surely very exciting, Chris, to understand how natural language processing or voice technology can make a big difference in safety, security, authentication, and exactly, as you mentioned, cross-sector. Really interesting to know that. Yeah. Quickly, I'll go back to Phil. Just trying to understand that I saw on your website quite a few case studies of aviation clients in US. How has Climacell made an impact on number of customers that you're working in the Asia Pacific region, maybe in air traffic management, maybe in other cross sectors? Phil, over to you.
Yeah, so our philosophy is the same regardless of which industry vertical we're addressing. So it's really focused on operational efficiency, safety, and revenue optimization. And so for like other industries around Southeast Asia, we've got a lot of the on-demand customers that we're working with. So naturally, you know, we've all experienced it. We probably noticed it early on in the days of on-demand when rain would hit, the price would spike incredibly high. But now it's a much more tempered response to that. And the reason for that is because they're leveraging weather data. So they get forewarning of when those spikes in weather will come. And they can mitigate that accordingly by, you know, adjusting the supply and the demand and promotions and stuff like that. And then on the other side of that, they also worry about their driver and asset protection. So very similar there. And then also in the construction space in here, once again, you know, their capital intensive machinery, there's workforce that are scarce. And so we're helping them to understand the weather conditions that will hit them ahead of time so that they can plan, mitigate, and optimize their operations based on the information that we're sharing, which creates efficiency and also safety. So that's how we're addressing you know, some of the industries here, and why we believe we can take that to the aviation experience space here in the Asia Pacific region. And as you mentioned, we've got the expertise from you know, our clients in North and Latin America as well.
Is there anything in specific, Phil, you would like to talk about, any of your customer references in Asia Pacific region, anything to do with air traffic management, or how are you trying to integrate the weather data for air traffic management for any of your customers and probably ground services? Of course, it was before COVID, things were at a different, and now we are at a different plateau. But would you like to discuss any of those work that you have done?
Yeah, so in terms of the aviation work that we've mentioned, so as Hugh alluded to earlier, the air traffic management space, there is you know, different requirements there. So our aviation experience has worked on the on-ground operations, and there's still a tremendous amount of impact and value we bring to the table there. So for the ground operations, there's many stakeholders involved in the airports, and so we work with both airports and airlines to help them understand the weather conditions that are coming towards them, converting that into like insights so that they can then act upon those. And it's such a, you know, as everyone is aware, a capital intensive industry that even just, you know, incremental improvements there, our work with JetBlue, you know, they're talking $75,000 per minute of cost. And so for us in their winter operations, understanding, you know, ahead of time which de-icing fluid, and then in the summer times when lightning electrical storms are coming, helping them, you know, just shave off minutes of efficiency is huge amounts of money. And so, yeah, we understand the value that we can bring at the ground level, and we know that we can also bring that to the air traffic management space, and that would, you know, benefit everyone on the call there in terms of, you know, operating aircraft more efficiently, less delays, more environmentally friendly. And that's why it's such an exciting space, and we're so excited to explore that further.
Yeah, thanks for that, Phil, those interesting comments. Surely ground services makes a big difference, especially in the tropical region. We have the heavy thunderstorms, rain, everything. Up north in Europe, we have the snow. Same in the US, there is always places like Chicago, so on. There are pretty much many issues around snow and so on. So very interesting to see, and how more and more innovations can come up in that space. I'll quickly move to Hugh. Something I was thinking about talking is, now Hugh, when we have this platform, which is AirLab, how do you see many of these startups of different sectors which are able to work together, and how are in coming together with the innovations for air traffic management, to be specific? You have already provided a platform. Thales is working with CAS, and then there are many startups trying to provide their APIs and so on. So where is that space for innovations, mainly for air traffic management, or what have we done so far in that area?
Okay, well, I think a hypothetical scenario might be worth considering to try and answer this. Let's say we have some parallel projects with multiple startups. addressing slightly different topics, but to be converged on the air traffic management system itself. Having the open platform, first of all, and the open architecture of that platform, which would support the provision of data to these startups to do their, let's say, specific application level solution. But it's also a platform on which they can make the results of their application available. Okay, so to publish the results of their algorithm, if you like, on the open architecture in a relevant and standardized service. And obviously, as entities such as third parties outside of the Air Lab, startups or innovation hubs, etc., are publishing more and more services on that platform, the platform becomes richer. And any service on the platform which is intended to be there for collaborative purposes will be published and open to use by other clients who have the valid access to the platform. So in that sense, the whole platform is somehow self-perpetuating. The more engagement we have, the more potential services we have, and the more potential value that's brought to that platform by the third parties. I think, I'm not sure if that's really answering the question as such, but I think that's the crux of it, that an open ATM platform is really open for all, in the sense that it would be a feed of information and data to enable services, but also the feedback from those services onto the platform to add to it, so to add more data or to add more services onto the platform.
Yeah, you've definitely answered that, Hugh. What I was specifically trying to get to is, now you have this, now the solutions for, especially for Air Lab, is more towards air traffic management, but you have all kind of startups coming with their solutions, probably in healthcare or logistics or voice technology or natural language processing. How are you really converting their solutions or their algorithms to more diverted towards air traffic management, if that makes sense?
Yeah, okay, so here's where let's say the concept of operations of what the air traffic controller is actually doing, and what the airspace and airline operators are actually trying to achieve in their operational goals. So the first and fundamental thing is safety. Okay, aircraft need to move around on the ground and in the air in perfect safety scenarios. Okay, there should not be conflict. There should not be risk of conflict. And when I mean conflict, I don't only mean with other aircraft. I mean with severe weather as well. So, taking an example of, let's say, Phil's example with Climacell, of having a more frequent and more accurate forecast of convective weather can make a big difference to the safety and the comfort of air travel. Okay, just think of the turbulence you might feel as you fly through a storm front, as opposed to if the pilot was given the freedom and the information necessary to avoid that storm front. So that's one example. Another example is from Chris's side, using advanced, let's say, signal processing in terms of voice to text transformation or audio to text transformation can make a big difference in complexity and the pressure on the air traffic controllers. In the future, take COVID away, and the future would be a lot closer in terms of the complexity I'm about to talk about. But in the future, the complexity is going to multiply by several factors for air traffic controllers, because we're reaching the tipping point between the optimization of airspace versus the number of people required to make decisions within that airspace. And it's getting to that point where you can no longer reduce the size of the airspace in order to reduce the complexity, because reducing the size somehow actually ends up increasing the complexity as you have to coordinate with more and more surrounding airspace elements. So in order to enable controllers to make critical decisions under a controlled and predictable way in the future, with ever increasing complexity and density of air traffic, there's going to be a need for integration of many advanced technologies into the operational concepts. And a very simple one is voice-to-text transformation. Okay, we could put in a voice-to-text transformation to understand what is being transmitted over the VHF frequency by the controller, and use AI or machine language algorithm behind that to understand the context of that instruction that's being given by the controller, and then monitor the same frequency for the feedback from the pilot. Now, quite often the VHF signals are not so easily understandable, quite noisy. So first of all, there are quite advanced signal processing techniques to use that use AI to clean the signal, first of all, and then to be able to transform that into text, and therefore enable, let's say, the further processing of that text to do matching of the correct readback of the instruction by the pilot. Now, this is a very critical one, because if the instruction to the pilot is to turn right heading 270, and he responds with turn right heading 170, but the controller doesn't pick that up on the noisy VHF line, then there's an inconsistency between what the ground system believes the aircraft is going to do and what the pilot is going to actually do. Okay. Now, either the pilot has made an error with his actual vocalization, or he's actually incorrectly understood the transmission from the controller. But in the background, if you have these technologies integrated, you can actually have that automated check to alert the controller that, hey, the response from the pilot was not correct. You need to check. Okay. And this is a key thing for safety in the complex world in the future. And more and more of these safety critical decision helpers or checkers, reminders, are going to become part of the concept of operations of air traffic management. And the use of AI and ML somehow gets questioned for, well, is it safe? Is it trustworthy? Well, we don't talk about AI or ML trying to replace a human. We don't talk about it doing actual separation of aircraft. We talk about it being an advisory, helping the human deal with complexity. And that human in the loop in the decision process of what to do with the information coming from your advanced algorithms is very important to keep in the context of the concept of operations.
Yes, fully agree with you on this, because one of Sentient's vision is how do we benefit humanity with augmented intelligence. So how do we augment intelligence? So we are looking at environments where AI and humans work together. Some people call it centaur model, right? Humans and AI working together, and that is the key, right? For air traffic management, as Hugh has said, safety is a very key thing. And so human interaction with AI should be natural, and that would be the voice aspects or even touch aspects. And one day when we get to it, brain-computer interface, BCI, would enable us to work at the speed of thought, right? The moment you think something, the action happens. And so that's where innovation in AI is going down the path. Pretty exciting.
Very interesting, Chris. So would you like to just pick up that thread of adoption of artificial intelligence into air traffic management or through other enterprises? So whenever you're working probably with your customers, and there are big and small enterprises, are they very risk averse the moment they hear about artificial intelligence augmentation, or they're fairly open in countries like Singapore, in rest of ASEAN? With what mindset do they approach artificial intelligence, if I may put it that way?
Right, very good. In our experience so far, we have not met an enterprise who is saying that they're very reluctant to implement AI because of either fear of job loss or something. Many of them are very keen in exploring how they can put AI to augment human intelligence. So you have that, again, there's the augmentation of human and AI together in their work, right? So for example, in the case I quoted earlier, in Japan. So that's this manufacturer who, up to today, they've been using humans to do visual inspection of their final products, and they produce high precision steel products. So it's very, very difficult to detect. So even if there's a hairline crack or a small smudge, that is a defect, right? So for them, they are really eager to look at how AI can help the humans there, as not many people wanted to work in that kind of environment in a hot factory, spending so many hours just looking at the products, right? So to augment humans, what is done is that we put AI down there to classify the defects. So when the defective product comes out of the production line and is flagged as defect, the humans can actually then decide, okay, what do we do? Do we send this back or do we cure it? And so we found that there are many enterprises more than willing to adopt AI. But more often than not, their problem is, where do we start? That is the problem. Where do we start? There's just so many things. So where do we start, right? And so that's the thing that we need to slowly handhold the enterprise and walk with them through this journey to discover out of their whole stack of problem statements which ones are best taken care of by AI. So we don't want to replace the humans, we want to augment them.
Yeah, Amartya, if you allow me to reflect on air traffic management there, because obviously let's say the user we normally talk about is the air traffic controller, but they're not the only user in an air traffic management system. There are the people who technically operate the system. They're the ones who maintain the system. They're the ones on the supply chain for repairs, etc. And there's many aspects of what AI or ML could be applied to in that overall ecosystem of what an air traffic management system is. But exactly what Chris said there is that quite often people are not so much afraid of AI or ML replacing them in any way, but they don't truly get yet what exactly it's going to do for them. And as he said, we need to hold their hand and lead them through the journey, show them through explorative research like we're doing here in our lab, to help them understand where the benefits lie in using some of these techniques.
So just picking up on that, Hugh, do you see that the regulatory framework, especially in air traffic management, having a very high importance on safety of aircraft and passengers and ground movements, how has that regulatory body, I'm not talking specific to CAS, but overall, globally, have they been very perceptive, very open and inviting for these artificial intelligence, these kind of technology, or mostly you have to overcome the hurdles from a regulatory framework point of view?
Okay, so first of all, in terms of regulatory framework, you have to realize that regulation for, let's say, safety or security, etc., are really about guidelines. In some cases standards, but mostly guidelines. Guidelines on what you should achieve as a minimum capability in your system, for instance. And none of these guidelines or standards prohibit the use of any specific algorithm or technique. But what they do generally require or advise in terms of a guideline is what you should do in order to satisfy the regulatory environment that the system is safe and is secure. Okay, and historically, that's in the air traffic management industry in terms of safety. It's led to, let's say, quite a heavy engineering process, heavy in design, heavy in traceability, heavy in testing, and heavy in let's say analysis of maintainability and analysis of let's say failure modes and recovery modes of operation. Use of AI or ML or specific algorithms in an air traffic management system are not specifically addressed by regulation. Now, if ever an artificial intelligence agent or a machine learning algorithm is, let's say, put in charge of unilaterally separating aircraft, then that would be a different question. Okay, let's say the framework requirement on making sure that the achieved result of that agent or that algorithm is safe operation of the airspace could be quite demanding and could be very challenging, let's say, academically, as to how it could be proven that a non-deterministic algorithm could be proven to be safe. You know, in other industries, they're dealing with this now, and you know, the autonomous car is a classical case where, you know, AI agents and machine learning are being used on board cars to perform, let's say, critical decisions that have consequences related to human life. And maybe some people will be aware of the studies being done by MIT and others about, let's say, let's say, what is the right decision to make? Should the car that has no other opportunity to hit the homeless person on one hand, or the mother and a child on the other, what decision should the AI agent take? Well, there's no good decision. There's only bad decisions. So it becomes more down to a question of ethics and goes a little bit beyond that to question of value to society, and it opens up a whole lot of aspects that are not at all related to the domain, not at all related to the accuracy or safety of the algorithm in terms of operating a vehicle or, let's say, separating aircraft, but it's more about, well, who gets to decide the value of one person's life against another person's life. So getting back to regulation, there is no blocker, but to satisfy a regulation, if you ever wanted to go beyond human in the loop, I think would be a very, very challenging task.
Well said, Hugh and Chris. Let me quickly go back to Phil. Phil, do you see that the pace of digitization, and especially due to COVID in the last 1 year or so, this has also pushed more and more augmentation for be it ground services or artificial intelligence or machine language processing, so on, into your field of expertise? How is Climacell, are more and more companies more open to using technology, especially in your domain? How has your experience been?
Yeah, so like any crisis, it does present an opportunity to look back and reflect. And even though the aviation space has been hit so incredibly hard in the past 12 months, there are, you know, our clients have renewed, and then we're still seeing more interest from people to understand how, you know, weather is impacting their operations. And we're even hearing the discussions around, you know, we know that for the next period of time, social distancing and those types of things will be around us. And we know that, you know, delays for trains, weather events do cause crowding and congestion. So clients sort of raising these topics, looking at how weather actually impacts the operations for their, you know, management of safe distancing, social distancing and so forth. So there still is interest out there. And also in the recent, you know, we are seeing more extreme and frequent weather events, you know, in the US in the storm season, but even here in the protracted monsoon season. So people are now starting to get an awareness that I can actually, you know, understand weather on my operations and take action to my advantage. So we're definitely seeing that. And then also the weather space has been interesting in terms of the aviation sector is one of the, you know, weather impacts it so much that they are critical observers of weather. And so the aviation industry, the air traffic management, you know, they are observing weather at airports and they are putting into global models. We saw that there was a dramatic decrease in observations with the decrease in flights globally. And so our technology being able to, you know, ingest other sources of weather data to supplement missing ones has been very much a strong talking point at the moment. So you know, obviously it's been challenging for the industry. We hope that, you know, there is a path forward sooner rather than later, but it has brought about the opportunity for us to sort of start to collaborate with AirLab and for other people to think about their operations and approach us.
Thanks for that, Phil. Very interesting to note that every crisis is also somehow augmenting or increasing the pace of digitization and automation. And we all are hoping things will go back to the same pace. And then we were all dealing with these problems just 12 months back. So we had the airspace congestion and every other problem, ground services. So these all solutions developed meanwhile would definitely help us. I have a few questions from the audience. I suppose I'll pick up some of them. One question is, apart from weather forecast and AI applications to air traffic management, what other potential technologies from startups can be applied? I open the question to all the three panelists, whoever would like to answer that.
Well, maybe can I lead off there, here? Look, I think there's no real foreseen limitation as to who or what could be applicable, because we really do expect discovery here as well as predictable elements of bringing in value into the air traffic management domain. I think Chris touched on an area with voice recognition or speech-to-text processing, because it's an element of data that is somehow, by the nature of its analog separation in terms of interpretability or shareability amongst consumers, sort of limits some of the current application of using that data. And getting onto the word data, data is something that is going to be, let's say, leveraged further and further. We hear it all the time, but it's really going to happen. I believe that a lot of let's say contributors to understanding data, understanding relationships between data, being able to derive consequences from data relationships will find a place in air traffic management. And when I say air traffic management, I mean the efficiency of operation globally. And Chris mentioned, okay, a train being late might cause crowding at the check-in or something like that. You know, it might also cause delay in departure of an aircraft. And that delay in departure of that aircraft might cause delay in downstream transfers of both freight and passengers between other aircraft at a hub. So that whole network effect is something that's quite complex to work out what all the relationships are and all the possible consequences are. And I believe that companies who can bring capabilities about the bigger picture of how the data can be leveraged to mitigate, let's say, breakdowns in the system in terms of efficiency, they'll find a place in air traffic management.
Chris, would you like to add anything on that, or Phil?
Well, I've got another. In my mind, there's another very interesting application of AI is in tracking the apron activities. You know, when the aircraft is parked at the air bridge, there are many activities happening: refueling, delivery of meals, luggage loading. You know, it's very ideal to have computer vision technology to just track and monitor all the activities that are happening around the aircraft, and then start measuring that, you see. So, and this is important to do things like deconflicting of that small space around the aircraft. That's one thing. Or how to optimize it, or even to measure how fast a particular activity has happened, like refueling or like loading up the meals and all that. And I think there's a lot of applications for computer vision technology for that kind of operations as well. And also safety management, right? You don't want somebody walking around when refueling is happening. So anomaly detection using computer vision is important. What if somebody left an FOD, an object somewhere near the aircraft, and then they just left? Right? So all this is important.
Yeah, I agree, Chris. And all that, let's say, computer vision data about the movement and the operation around the ground is something that feeds more into that network effect, the whole optimization question.
Yeah, exactly.
And then I think that feeds into your point, Hugh, of having open data and data available, so that then more people can start to use that, and you have that flywheel effect in terms of instantaneously, as Chris mentioned, the supply chain, having all of those elements together and someone being able to see the full picture.
Right. Very interesting comments made by all three of you. We are running short of time and running out of time completely. So what I would request, probably go back to Wyman. But before that, I would like to thank all of you, Phil, Chris, and Hugh, for sharing your comments, sharing your experience. And all of us hope that all these automation, digitization, artificial intelligence, we can augment them more and more, not only into air traffic management space, but beyond cross-industry. And this platform, which has been provided by AirLab, is also a very interesting one, where many startups can come together and make solutions which can be applicable industry-wide. So with that, really like to thank all of you for your time, and going back to Wyman.
Thank you, Amartya.
Thank you.
Thank you, Amartya, bringing up great questions and discussions with the speakers. I hope everyone from the audience here has something to take home today and learn more about the applicable technologies to ATM systems. Unfortunately, we have run out of time in answering all the questions that came in today. However, I'll be launching a very quick poll here. Do let us know if you may be interested in connecting with AirLab for future conversations. So you can just, let us know. While that being said, I would also like to represent SGInnovate to thank all the attendees who have stayed with us until now. I would like to say a big thank you to all our speakers, Chris, Phil, and last but not least, Hugh, for all the wonderful sharing for today's webinar. And also to the attendees again, do keep a lookout to our post-event mail, which will contain a recording of this session. And do reach out to us at events@sginnovate.com if you'd like to connect with any of our speakers or to have a chat with us for collaboration opportunities. Do also remember to give us your post-event feedback when you exit the webinar or through the post-event mail as well. So let me just end the polling. And yes, with that, this is Wei Min signing out from this webinar. Hope that everyone will have a great day ahead. Stay safe, stay healthy. Hope to have you again in our next webinar session. Goodbye.
Bye-bye.
Bye-bye.
Thank you, everyone. Bye-bye.